Okay, a little more on p-value. Okay, so again, p-value. P-value is this probability. Okay, it's this probability of observing data like yours and again more extreme, okay, usually out farther from whatever our null hypothesis is, if H0 is true. I don't know why I put the colon there. So that's the key, right? Is we're going to make a calculation, and that's our probability. So we calculate p-value based on H0 and our data. Now, this is a good point as to why our data is always part of the alternate hypothesis. It's not supposed to be part of the null hypothesis. Now, it could be that your null hypothesis could be you have a fair coin, you flip the coin 100 times and you get 50 heads and 50 tails, in which case your data landed on your null hypothesis, but ahead of time you wouldn't have guessed that that would have really happened, 51 heads, 49 tails, that kind of thing. So, you shouldn't, you would never base your null hypothesis on your data. You would always pick your null hypothesis first and then go gather your data. But that's just what we do. We calculate this p-value. It is just a probability, and it is this probability every single time. No matter what hypothesis test we're running, no matter what data we have, no matter what our null hypothesis is, as long as all those things are correct, that is all we ever do, is we calculate this p-value, which is that probability of observing data like ours and more extreme, if H0 is true. Every single time. Never changes. And it breaks my heart when at the end of a semester I have students who haven't internalized this. Now, it breaks my heart, but honestly it's not unexpected after seeing this for years and years and years. This stuff, it is hard. I'm stating it here as if it's easy. It's this one statement, learn it, know it, yep, and in that way it is that easy, but it's not. Okay, so this is something you have to work at. Okay, but that is the probability, this p-value thing that we calculate every time is simply and only the probability of observing data like ours and more extreme if H0 is true. That's it. And if, as we saw in the court case, right, if p-value is small, now small can be a relative term, but for us, less than 0, in almost everything we do in this class, less than 0.05, and your prelude, hopefully you watched that. You watched the prelude and you played the game, but the prelude game, if you haven't done it, go do it, gives us actually a reasonable idea as to why this 0.05 makes sense. Now, when I play the prelude game, I get about 0.10. That seems to be my natural threshold, I guess. So, you know, I guess I'm more likely to convict somebody of a crime. I don't know. I don't mean that lightly, but actually I have been on a murder trial, so I've been there. I mean, I wasn't, you know, being tried for murder. I was a juror on a murder trial, and so, you know, you know, but when I look at their data in the prelude game, I quite consistently seem to be somewhere around the 0.1 mark as opposed to the 0.05 mark. But it still gives you an idea as to where that number comes from, and it is a reasonable number. And again, as we talk about errors in another video, we'll hit that number some more. But so if the p-value is small, we reject H0, or the null hypothesis. Okay, because that p-value being small says, you know, if that's true, okay, well, not the reject part, if H0 is true, if the null hypothesis is true, then the probability that we could have seen our data is really tiny. So why should I believe that? Okay, so that's the idea with p-value, is if we want to reject, we want it small. If we don't want to reject, we don't want it small. Now, usually if you're setting up a hypothesis test and you're performing an experiment or some kind of observational study, you do hope to reject the null hypothesis. You know, that's what you're hoping for. But we will see later in the course where there are cases where actually you'd prefer not to reject H0 because of what you're doing. It's all about context, and it's simply a tool. It is a tool to help us all kind of arrive at the same numbers. And that's always a nice thing. If we can all understand somebody else's justification, and we all understand the model they're using and how that works, well then, you know, we can still decide to agree or disagree, but we understand the justification that they're using, and they would understand the justification we are using. Okay, so that's a little more on p-value. Again, you know, if p-value is small, we reject. I don't know, I'll have to try to come up with a rhyme or something, and maybe I can put that in some other video. Rhyming, it's always a good thing. All right, so we'll call that good.